Hey guys, welcome back to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akini, your math instructor, and in today's video I'm going to be spending more or less say an hour or so with you on this particular video. And in my two previous upload that has been related to this particular topic, I had gone through detailed explanations of the fundamental principles of understanding circle geometry, as well as I had made a video explaining theorems 1, 2, and 3. But it's around exam time at the point where I'm making this video, so I'm quickly gonna jump into working some exam structured questions, so you may understand a few of the theorems, as well as you may not, as well as you may have to rely on your prior knowledge of this topic so you can completely understand what is going to be done in this particular video. All right, but if this is the first time here on the channel, I primarily focus on helping students at the CSEC, CC, SLCs, SEA and CAPE level exams for the Caribbean, and I primarily focus mainly on math. All right, so we're gonna get right into the video. Leave me a like, and of course leave some comments down below, guys. Questions, suggestions, video requests, and I'll do my very best to get to those videos as soon as possible. All right, so let's just jump right into the video now, and we're going to be looking at about 5 years or so, 5 years January and May exam papers, running from about 2018 all the way to the most recent exam, 2023 January. And hopefully by the end of this video, you guys will be able to have a complete, clear understanding of how it is that you approach. I'm going to be teaching you the approach to the question, what's the first thing that you should do when you approach the question, and what are some of the clues, tips, and where you can find in the question so you can comprehensively breathe through this when you face a question like this in the exam. So without further ado, let's jump right into the video. Alright, so I'm putting up my document here, guys, and the first question here that you are seeing here on screen is in fact the May exam 2018, and this was the question that they had sent for this particular year. Here you can see right here, it is the year 2018. All right, so I'm going to be going through some detailed working out with you here, guys, and just spend some time with me here. Use this as a practice session. After this video, you should be able to take a break and move on to something different. So let's get right into the video. All right, so we're going to start off obviously by reading the instructions about the question. And it says here that the diagram below, not drawn to scale, shows a circle with center O. Let's just identify that from now. Center O. The points A, B, C, and M are on the circumference. This also is going to be a very good key. You guys need to get familiar with actually knowing this particular statement. That's also a clue to what we're going to be using to solve for any particular angle in the question. Continuing, it says that the straight line CN is a tangent to the circle at the point C, and it's perpendicular to BN. So those two keywords here, tangent and perpendicular, also helps us. Let's look at the tangent CN. Here, the tangent CN is right here, and it is perpendicular, as they said here, to BN. So the mere fact that BN and CN is perpendicular, you can see the exact reason why there is a 90-degree angle indicated at that position there. All right, and so far that's all that they have given us regarding the question. They've also given us an angle here at CAB to be 58 degrees. Now, what I want to do though, guys, is that as you're approaching the question, don't just go ahead and try to answer the question directly. What you want to do is that you want to try to use just your basic knowledge of geometry to help you with finding certain angles before you actually look at the question. That's one approach. All right, now as I mentioned to you before, that whenever in any instance, as you're going to be seeing throughout this video, you may see it once or twice that whenever it is that they say that 4 points are on the circumference, then that is a clue to letting you know that there is a cyclic quadrilateral that is inside this circle. And this cyclic quadrilateral here is in fact made by the points A, B, M, and C. All right, so that basically creates what is known as our cyclic quadrilateral. Now there is a rule as it relates to circle theorem when it comes to the cyclic quadrilateral, and so that rule is that we need to know that the opposite angles in a cyclic quadrilateral, they are supplementary, which means that they add up to 180 degrees. So that's rule number one. So right away, I will already know without even looking at the question that this angle and this one down here will sum to 180 degrees. So I can already say here that this angle, if needs be, will be 180 minus 58 degrees, which, as I said, if needs be, I can write my answer here. All right. And we already established that BN and CN are perpendicular, so there's a 90-degree angle here. So therefore, we can say that this angle here and this angle here in this triangle BCN, they are going to be complementary, which means that those two angles will sum to 90 degrees later on if we need to find that. There's in fact two right angle triangles actually. There's one here that is at the bottom. That's one down here. And that little right angle triangle is in fact inside of a larger right angle triangle. So that also is our assessment of this particular diagram. I don't see any more clues except that, you know, a couple of theorems might come into play where we need. So let's have a look at the question to see what is it that they have asked me to do. So that's what I encourage you guys to do. Before you actually attempt the question, you need to analyze what can you see on the diagram. Do you see triangles? Do you see isosceles triangles? Do you see quadrilaterals? All these things are clues you need to pick up before you approach the question. If you don't, then you're going to find it very difficult in trying to find the angles that are required. So let's jump right into it here. It says that we're to determine, giving a reason for your answer, the angle that is marked at B, and it's made by A and C. So A, B, C, we're looking for this particular angle right here. All right, we're looking for that particular angle right here. Now, we don't have a lot of information, guys. We don't have a lot of information, but we can definitely try to figure something out here. All right, so one thing we do, or one thing that I recognize here, is that if we look back at theorem number 5, all right, it's what I call theorem number 5, is that whenever it is that there is a diameter that is inside the circle, then if the diameter subtends an angle, and when I say subtends, I mean creates an angle. If the diameter here, here's a line projecting from one end of the diameter B to the point C, and it's another line being projected from the other end of the diameter A to the point C, then if the diameter subtends an angle at the circumference, then it means that the angle right here is going to be, say here, 90 degrees. So we can start off by saying that here, that we can start off by saying that triangle ACB is right angled since AB subtends an angle of 90 degrees at the circumference. Right, so that's the reason why I say that this angle is 90 degrees. So with that information, then we can make a conclusion and we can say, therefore, the angle which we're looking for, which is angle ABC, is going to be equal to 180 minus the 90 degrees that we had just looked at plus the 58. So if we do the math here, you'll find that 180 subtract, say here, 148. This should give us an angle of 32 degrees. All right, and then we can actually add another statement here if we so desire, to say that the sum of the angles in a triangle are supplementary. All right, so for 2 marks, that's what it takes. All right, now I can't say for certain if it is that you have to write the 2 statements for safekeeping. I suggest that you do if you can remember the theorems or the statements, or if you can just simply write one statement that summarizes both. If you can use one geometric statement that will involve everything that's related to helping you to find that particular angle. So this angle here is 32 degrees, and I strongly encourage that every time that you find an angle, then you insert it onto your main diagram. It gives the diagram a bit more life. All right, beautiful. And that's how we take down that particular first question here. Now we have a few more questions related to this here, and it says that we're to find the angle that is marked at M made by the line C and B. All right, so C and B, let's have a look at that. Angle CMB, and it is that angle, and here you can see CMB. Notice that we had already indicated at that angle prior to us even looking at the question. And we had already established that if we needed to find this angle, then it would have been 180 minus 58 simply is going to be equal, say here, to 122 degrees. All right, and we knew the reason why we said that, because the points A, B, M, and C are on the circumference, which makes that a cyclic quadrilateral. And so one of the geometric statements related to the quadrilateral inside of a circle is that the opposite angles are supplementary. So let's go right over here. So we're going to say, therefore, angle CMB is equal to 180, take away 58, which is equal to 122 degrees. And so the reason why it is so is that the opposite angles in a cyclic quadrilateral are supplementary. Okay. Which means that they add up to 180 degrees. All right, and that is how you find that angle. So it does help, and as you're gonna see throughout all these, I believe about 8. I believe it's about 8 past paper questions. As you're gonna see that a lot of the times when I'm approaching the question, I always tend to look for clues before looking at what they're asking me to find. All right, and so finally in this particular question here, we're going to be looking at finding the angle NCM. So the angle NCM, so this is 122. So the angle N, okay, let's see here, angle NCM. So it is this angle down here, this little one right in here, that is going to be the angle that is inside of the smaller right angle triangle. That's the angle that we're looking for. All right, now let's see what we can do here. All right, let's see what we can do here. Let's have a look at any clues that may be available here for us. All right, so now since the angle, or since angles that are formed at a point on a straight line measures 180 degrees, then if we look carefully here, that if we could perhaps some way somehow find this angle here, then I can easily connect this angle with this angle here. All right, now we can find this angle here by simply subtracting 122 from 180, and that should give me an angle of 58 degrees. All right, and then the reason for that would have been the fact that angles at a point on a straight line sums to 180 degrees. So now that I found that angle is actually 58 degrees, all right, now that we found that that angle is actually 58 degrees, then we could simply say then that the sum of the angles inside of a triangle, so we could come here and we could say that this angle therefore is going to be 180 minus 90 plus 58, and therefore that's going to be 180 minus 148, which again, as you can see here, is 32 degrees. All right, you can see that that angle there is 32 degrees, and so the reason for that is also the fact that the sum of the angles in a triangle sums to 180 degrees, and those would have been the two geometric statements that we needed to actually estimate the size of this angle here. And by now you should be actually looking at the fact that this 58 up here seems to be somehow connected with this 58 here. Even though we didn't use this 58 here to actually calculate and calibrate that it was also 58, you would also recognize here that there's also a geometric statement related to the quadrilateral inside of a circle that states that the exterior angle, and that is the angle that is found outside of a quadrilateral when one side is produced, then if this angle is on the outside, then it's going to be equal to the interior opposite, the angle that is opposite to the interior of that angle. So that's also another reason why that angle is also 58 degrees. All right, and as you can see here, this angle also here is connected to the angle up here, which is what we found here to be 32. All right, and there's a couple of reasons why that angle is also, say here, 32 degrees. Because also you will find that this angle over here is going to be also 32 degrees also. All right, because the angle that is formed between a tangent and a chord is equal to the angle that is formed by the chord at the circumference of the circle. All right, so there's a lot of connections that you're going to see. A lot of times I've heard students say that, oh, they can find this angle by just looking at that one. Remember, there has to be a geometric reason as to how and why, how you got your angle and why you say the angle is what it is. All right, so it's very, very important here that you do not induce in your mind any form of guessing. You need to be geometrically it needs to be geometrically confirmed. Okay, all right, and that brings us there to the end of that 2018 paper. Let's then have a look at the 2019 exam paper here, and this was one that was sent in January of 2019. So let's have a look at this one. Now once again here, let's go ahead. It says here that the diagram below, not drawn to scale, shows a circle. And again, guys, as you can see, for repetition purposes, the points P, Q, R, and T, sorry, the points P, Q, R, T, and V are, well, it should have been are on the circumference. Q, R, and S is a straight line. The angle PVR is 75, so that's the angle PVR, and the angle TSR is 60. The angle TRS, pardon me, not TSR, but TRS is equal to 60 degrees. All right, and so we can see here that since the points P, Q, R, T, and V, more than likely, since there's 5 points on the circumference, then it means that at some point you may find 1 or 2 cyclic quadrilaterals being inscribed inside the circle. Let us see if we can identify those cyclic quadrilaterals from now, because that's what we do. We identify the clues in the question and try to form a relationship between the angles from early. So I can clearly see here that PT RQ connected back to P forms a cyclic quadrilateral, because all those 4 points are on the circumference. So right away I'll know that this angle plus this angle sums to 180. And I will also learn here that, say here, this angle, all of this and all of this will sum to 180 degrees. So that is also a clue that might help me a bit later on from now. We can also identify another cyclic quadrilateral here, which is connected by VT. And I'm going to overlap this red line here. Okay, I'm going to overlap this red line here. So that's PQ connected to R back to here. So that green line there forms also another cyclic quadrilateral. So once again, you'll see inside the cyclic quadrilateral that this angle here plus this one here sums to 180 degrees. Pardon me, that's the incorrect one. This 75 degrees, and this angle down here also will form 180 degrees. All right, so we had already indicated that that angle and this one, this red one here and this red one, will add up to 180. And I also confirmed that the overlapping quadrilateral here forms that this one and this one also will add up to 180. So it means that I can use this angle to find this angle, and therefore use this angle then to find that one if needs be. That's not the only thing here, guys. Let's have a look also at another supplementary angle here. This angle right here, inside here, along with this one inside here, will also form 180 degrees. So pay close attention to how I've color coded the angles that sums to 180. So later on now, when we look at the finding any particular angle inside here, we'll already know which one is connected to which one. All right, we also recognize that there's an angle that is on the outside here. Okay, there's also an angle that's on the outside, so that would also bring into play what is known as the tangent theorem, that states that the angle that is outside of the circle that is subtended by a chord on a tangent will be equal to some particular angle, which we are going to have to identify if needs be. Also, this is also an exterior angle that is outside of the quadrilateral that is marked by red. That's also an angle that is on the outside. So somehow this 60 degrees will be connected to an angle that is inside here. All right, and this is what you want to do when you go into the exam, guys. Probably in this video I'm taking a very long time to explain these things, but when you go into the exam, this is what you want to do. You want to be able to pick up on the clues before you actually approach the question. Now that we have sufficient clues, let's have a look at what they have asked us to find. It says here that to determine each of the values of the following angles, show detailed working where necessary and give reasons to support your answer. And the angle in question here is the angle PTR. So let's have a look at that. That is the angle PTR. We had already indicated that by searching for clues that this angle here is going to be added to this one to give us 180. So we're having a problem here because the only relationship between this angle that we have is just the one down here. And there's nothing in this diagram to help us. So it means that maybe if we can form a connection between this angle and another angle, we'll find that this angle should be able to, we should be able to find this particular angle here. All right, and there's actually two ways in which you can find this angle. I'm going to show you both. All right, now notice that we had already indicated that very same angle that is marked in red, we had indicated it marked in green, because this angle that is marked in green will be able to sum to 75 degrees. And if it is that we subtract 75, say here, from 180 degrees, we should be able to get the angle that is marked in green, which also gives us the angle that is marked in red. So we can go ahead here and we can safely say that the angle PTR, all right, this is our start out, okay? First, we have to find the angle PQR. So angle PQR is equal to 180 minus 75, which is therefore equal to 105 degrees. And we have to give a reason for that. The reason for that is that the opposite angles in a cyclic quad equals 180 degrees. All right, that's the reason why we got this 105 degrees here. That 105 goes for both the green indicated angle and the red indicated angle. All right, and so therefore with us finding that 105 degrees, we can therefore say that the angle, which is PTR, is equal to, say, 180 minus 105, which is equal to 75 degrees. And so the reason why we got that is also because opposite angles in a cyclic quadrilateral equals 180 degrees. All right, so it's the same reason for us getting the angle, but we needed to find that 105 before we were able to find this angle here that is marked at 75 degrees. Now you should also be looking at this and you'll be like, okay then sir, then these two angles are connected. Why are they the same? Well, this also brings to life theorem number 4, that states that the angles that are formed in the same segment of a circle subtended by the same arc are equal. So if also here we are smart enough, let's see if we're smart enough now to connect, say for example here, the line P to R, then you'll find that the chord or the arc PQR, the arc PQR forms an angle of 75 degrees. Notice that the two green lines are projected from the end of the blue line. The two green lines are projected here. And also from that same blue line here, we see two red lines being projected also in that direction. That also brings us to the fact that we could have actually found that angle 75 degrees by using one very simple statement, that the angles in the same segment of a circle, angles in the same segment of a circle are equal. So that's also another way that you could actually find that 75 degrees. But then again, sometimes you'll see it, sometimes you will not. Sometimes you may have to take a longer route to get to your answer. But as long as you get to your answer and you can geometrically support how you get to your answer, then it does not matter. All right, well done. All right, so hopefully you guys got some understanding from that. Let's have a look now at the angle TPQ. TPQ. So let's see here, TPQ. It is this angle that is indicated in purple. Okay, we had indicated that angle in purple. And we had also said earlier, notice that it's so good with this color-coded device that I have here, that once I can color code these, you can see how that purple angle here, TPQ, is connected to the angle all the way over here. So this angle over here is in fact, say here, added to this one here to give us 180. Now we don't know anything about any of the angles indicated by purple, but I did say to you earlier with this arrow here that 60 degrees is going to be somehow connected to an angle that is inside one of these quadrilaterals. And if we go back to like the previous question where we had looked at the angle that is formed outside of a cyclic quadrilateral, the rule states that the exterior angle that is formed on the outside of the quadrilateral, the cyclic quadrilateral, which in this case is the red one, the angle that is formed on the outside is going to be exactly equal to the one that is opposite to the angle that is interior to this one. So this here is the exterior angle, and then this one here is the interior of that exterior, and then this opposite purple angle over here is the one opposite to the interior. So we can therefore make a connection between the 60 degrees on the outside and the angle that we are intending on finding. So we can safely say then that the angle TPQ is equal to 60 degrees, and to support that we can safely say that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, and that is the statement that CSEC is looking for to support why you say that the angle TPQ is 60 degrees. So we can just indicate that from now, that the angle here is in fact 60 degrees. That angle that is marked in purple is 60 degrees. All right, so hopefully by now, guys, you're getting the whole idea of how I'm approaching the question, what I'm thinking about. If you notice that a lot of the work has been done during the process where I was looking for clues, because if I didn't look for those clues, then I would have to really work hard approaching the question to try to figure out which angle is connected to which one. You want to form a connection. You want to pick up all the clues before approaching the actual question, so that it's going to be easier for you to find a relationship between the angles. Okay? All right, so here we go. Next one is going to be obtuse angle. You are to find the obtuse angle POR, where O is the center of the circle. And we know that the term obtuse means that the angle is going to be greater than 90 degrees, but at the same time it's going to be less than 180 degrees. So it should be that the angle is going to be greater than 90 degrees, but at the same time it should be less than it should be greater. The angle should be greater than 90 degrees, but at the same time it should be less than 180 degrees. My apologies, guys. So that's what the word obtuse means. So we're looking for the angle that is marked at O, and this is the angle here that is the center of the circle. All right, let's see if there was an indicator here. There was no indicator at the center O, so we're gonna make an assumption that the angle here is at the center. All right, there's no indicated O here, but they did say, let's see here, they did say that the obtuse angle where O is the center. So let's just imagine that there was in fact a center. All right, we don't need to indicate it, but let's just imagine that there was a center. All right, and if we can perhaps say, let's just make an assumption that that is the center. All right, we're just assuming that that is the center. Then we know from one of the previous tutorials that I made, where we said that the angle that is formed at the center of the circle is going to be twice the angle that is formed at the circumference, provided that they are made by the same chord or the same arc. So if you notice that this 75 degrees here, we know this is not the center, but assuming that it was the center, then you notice that the chord PR made an angle of 75 degrees here, and it is that very same chord that we would also use to create the angle that is made at the center, and this assumed center. Even if we were to perhaps say put the center say here, or put the center say here, or put the center say here, it doesn't matter where we put the center, it is that very same chord that we're going to be using to actually create the angle at the center. So therefore we can safely say that, assuming that that point would have been the center, we can safely say that the angle POR is going to be equal to 75 multiplied by 2, which is equal to 150 degrees. And so the reason for this would have been the angle at the center of the circle is equal, pardon me, not equal, but in fact it's going to be twice the angle at the circumference. And we have to back up by saying that is made by or made or subtended by the same chord. All right, it's very important. You may get away with it based on how you write your statement, but as long as CSEC understands that you understand what you're saying, then I'm assuming that they should be able to give you full marks for that particular question. So your angle is in fact 150 degrees. All right, so 35 minutes into this particular video, guys, we've gone through 2 examples that has brought out a lot so far. Hopefully, if it is that you guys are gaining some value, do not forget to leave a like on the video. Let's go on to the exam year 2019, but it's the May exam. Let's see what they send that particular exam. So once again here, we are seeing here now that the diagram below shows a circle where AC is a diameter. That's a clue. That's a clue, because so far what we have learned, for example, in example number 1, where we said that if there's a diameter that is inside of a circle, then more than likely, if 2 lines project from the edge of those diameter, then more than likely a 90-degree angle will be created at the circumference. So right away, within the very first sentence there, I've already picked up my first clue that that angle right down here is going to be 90 degrees. So it's a right angle triangle there. And right away, I also know that this angle here and this angle here will sum to 180 degrees. Sorry, it will sum to 90 degrees. So in one line, I was able to pick up a couple of clues. Next, B and D are 2 other points on the circle, and DCE is a straight line. Let's see here. DCE is a straight line, which you learned in one of my previous tutorials, that DCE, which is an extended chord, is also known as a secant. Okay, if you were to extend it on both sides here, it would be called a secant. All right, but yes, it's a straight line. So they are perhaps trying to say then the angle that is formed here and here will sum to 180. Probably that's what they're trying to say. All right, and it says that B and D are 2 other points on the circle, on the circumference. So I also notice once again here, guys, I can pick up more clues also that say here the point A, the point B, the point C, and the point D, they're all on the circumference, which also brings up the fact that opposite angles in a cyclic quadrilateral are supplementary. So right away now, guys, I can form a relationship between the fact that this angle here and this angle, including the 46 degrees here, this angle including the 46 degrees adds up to 180 degrees. So if needs be and I need to find that angle, then I would know that that angle is going to be 90 take away 46. Because if this is 90, if this angle that is indicated in purple is 90, then it also means that this angle over here is also going to be 90 degrees. Right? Because that angle is also subtended by the diameter. So that angle is also 90, and I would have already had 46 out of the 90. So I can easily subtract 46 from 90 to get 180. Sorry, subtract 46 from 90 to get the remaining angle, which in the event if we need it, we can find it. All right. We also formed the fact that this angle, including the 28 here, this angle here, whoops, let's just remove that. So this angle involving the 28, so this purple angle and this 28 degrees will be summed together, and along with this angle here, you're gonna find that those 2 angles also add up to 180 degrees. So a couple of clues being formed here. Okay, all right, there's no tangent to the circle, and I think that's all the clues that we really have to work with. Let's look at what they have asked us to find. So here it says that we're to calculate the value of each of the following angles. Again, show detailed working where necessary and give a reason to support your answer. And we're in fact looking for the angle DBA. That's the angle that is at B. So that's D, which is here, B, A, and it is in fact the angle that we had indicated whilst we were searching for our clue. So you can see that just by searching for clues, forming relationships, you're going to find that by the time you get down to the question that they're asking to find, you'd have already had a very, very good idea of how to actually find that angle. So right away, we don't have to do much work here. It would have simply been the fact that angle DBA is equal to 90 take away 46, which you're going to find naturally here that this is equal to 44 degrees. And so a reason to support your answer would have been in fact that, well, you could actually say the opposite angles in a cyclic quadrilateral are supplementary, or you could just simply say, the easiest way here is to say that the angle subtended by the diameter equals 180 degrees. Sorry, subtended by the diameter, pardon me. Get my theorems a bit mixed up, guys. Equals 90 degrees. So because this angle is established to be 90 degrees, then that's why we are able to subtract the 46 from 90 to get the remaining angle, which is in fact 44 degrees. So let's just indicate that in here, 44 degrees. All right, pretty good. Pretty good there, guys. Next, we can move on to finding the angle DAC. So the angle DAC here, let's look at it. So the angle DAC, that's the angle indicated in purple here. That's the angle indicated in purple here. All right. So we already formed a relationship between the angle that is formed in purple up here and the angle that is formed in purple down here. So how can we actually find that angle? Now, we can't say for certain that the angles are equal because we can't say that the angles are equal because we don't know if this chord and this chord is equal. We don't know for certain. So there has to be some other relationship that we can form between that angle there. All right, let's have a look at that. Now, this is in fact a tricky little question, and it requires us to run around a little bit, and it's a little difficult to find it because the angle that we're searching for is inside of a triangle that has absolutely no helping information. So what I see here that I can do is that there's actually a relationship between the 28 degrees here and this angle down here. All right, because if I can somehow find a piece of angle inside this purple diagram, then I should be able to help myself out here. Because notice now I'm going to be highlighting another triangle here in pink. I want you to pay close attention to this triangle that is ADB, this triangle here. That's going to be helpful because I already have 44 and I have the 28. So if I can somehow find this piece of angle here, I would have had all the angles that I need to help me. So I need to find this angle here that I'm pointing at in pink. I need to find this angle in here. But to find this, I know that this angle here is 90. So if I can somehow find the angle that is marked by the black arc here, then I can subtract that angle from 90 to get the one that is inside here, and then from there we can take it. So now I can find this angle down here because notice now that the angles that are formed in the same segment of a circle. Now notice that here that the line BC here, the chord BC, it projects the pink line and it also projects a purple line that forms the angle 28 degrees. So the chord BC projects the pink line and the purple line to form the angle 28. But notice also that the chord BC also projects the pink line and this other purple line down here that forms the angle indicated by the black arc. So therefore, that suggests to me now that the angle that is down here is actually equal to 28 degrees. And so the reason for that, let's have a look at that angle. We can start off by seeing the angle BDC. So the angle BDC, so angle BDC equals 28 degrees. And the reason why we have said that is that the angle in the same segment of a circle are equal. So just by us identifying that, and that's a little challenging, I'm not gonna lie, it's a little challenging to pick up, but if you're able to understand how to use this theorem of how the chords will form angles at the circumference, then once you have established this 28 degrees here, then we can easily identify the one that is marked in purple here. Now this angle, sorry, not purple, the one that is indicated by the pink arrow here. So the angle that is marked by the pink arrow, we're going to give it a name. We're going to call it the angle ADB. So we're going to continue here. All right, so this means now that angle ADB is equal to 90 take away 28. And you're going to find that this is going to be 62 degrees. So this angle in here is going to be 62 degrees. And if you want to give a reason, you could say that the angles are complementary. And we know that complementary angles add up to 180. So a reason for that would have been that they are complementary angles. Complementary angles. Now that we have found some helpful angles here, let's have a look at the triangle that is marked in pink. That is the triangle ADB, the triangle ADB. So since the sum of the angles, so we can say that triangle ADB, right? Okay, let's just erase that here. So in triangle ADB, we're going to find that the angle that we're looking for in triangle ADB angle DAC, which is what we're looking for, is equal to, let's see here, it's equal to 44 plus 28 plus 62. So that's 44 plus 28 plus 62, right? And we're going to subtract all of that from 180. So that's going to be 180 minus the sum of this answer here. So 44 plus 28, so 4, that's 60. 64, that's going to be 72. 72 and 6, that's 132, that's 134, right? So you can confirm that, guys. Let me just double check on that answer. So that's 100, 128, 130, 134. So that's correct. So that's 134 degrees. And if we subtract that here, you'll find out that the answer here is 46 degrees. All right. So the angle ADB is 46 degrees. And we can confirm now with one more statement to say that the sum of the angles in a triangle, the sum of the angles in a triangle sums to 180 degrees. All right, so that was a tough question. Let's see how much marks it was worth. It was worth 2. Maybe there is an easier way to find it. There could be, but that was the first thing that I saw there. So it's 46 degrees. You can see that the angle here that we're looking for, that's the one marked in purple, is 46 degrees. So again, you can see why they've only given you 2 marks, because for some reason they are connected. And again, which I didn't see, that the chord DC projects the pink line and the red line to form the 46 degrees. And also the chord DC projects the purple line and the pink line to make 46 degrees. So we could have avoided all this hectic statements here, beating around the bush to get the angle. But like I said, sometimes when you're doing the problem, you don't necessarily see the exact theorem that will get to your answer. But sometimes you can go around the corner, go under the bridge, go over the moon, and you're still going to get to your answer. At the end of the day, that's what you want to show. You want to show CSET that you understand the whole geometry that's related to the circle. Alright, but the easiest way to get that angle of 46 degrees would have been to say that the angle, DBC is equal to the angle DAC created by the chord DC, which is equal to 46 degrees. Alright, so not bad, but sometimes that you're gonna find that a lot of the times when you take a longer route to get to one particular answer, you end up finding also another answer. Let's have a look here. The angle BCE. So the angle BCE, the one on the outside here. Alright, and you're gonna find here that since this angle is formed on the outside here, alright, since this angle here is formed on the outside, BCE, it is really an exterior angle of this cyclic quadrilateral that I'm indicated here in blue. So it's an exterior angle. And you're going to find that that particular exterior angle is going to be equal to the angle that is opposite to its interior. Now this angle is its interior. This one here is the interior to that exterior, and the sum of the 46 and the 28 will give us the size of the angle on the outside, because the angle that is on the outside is going to be exactly equal to the one that is opposite to the one that is on the inside. So easily we can find that angle BCE. So angle BCE is equal to 46 plus, let's see here, it's going to be equal to 46 plus 28 degrees. And that you'll find that the answer here is going to be 74 degrees. Right, and the reason why it's 74 degrees is simply because the opposite angles in a, not the opposite angles, pardon me guys, I'm getting my theorems a little bit mixed up. That's okay though. Alright, the exterior angle of a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral sums to, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Right, that's the reason why the angle BCE is 74 degrees. All right, so was this a tough question? Let me know in the comment section if it was tough. All right, we had to really dig deep. There were some other alternative methods which I didn't see, because I'm seeing these questions for the first time, so I'm literally working these questions based off first sight. I've not seen these before, so it's not like I had a pre-planned method. I'm just looking at it and then I'm just working according to what I see. But as I go along and I find that, oh, okay, so this angle that we had beat around the bush to find to get 46 is actually connected to the angle over here, which is 46, which makes the explanation a bit easier. All right, so hopefully that one was clear enough for you. Let's go ahead on to another question. And now we're going to be looking at the 20 circle theorem question. All right, so here we go. The circle shown below has center O, and the points A, B, C, and D are lined on the circumference. And this is for the fourth time or the third time that we're actually seeing something related to a cyclic quadrilateral. So the points A, B, C, and D are lined on the circumference. That means that more than likely some sort of cyclic quadrilateral is going to be there. So the points A, B, C, and D, well, it's not in fact a cyclic quad, but if we were to connect it, then it would form a cyclic quad. So let's just indicate that from now, that maybe that could be helpful. All right, it says that a straight line passes through the points AB, So a straight line passes through the points AB. They're trying to tell you that that's a secant. The angle CBD is 49, and the angle OAB, and if they say that there's an angle or there's a point O, that means there's a center, which means that there are going to be radii or diameters. There's going to be a radii, or there's going to be radii, or it's going to be a diameter, or both. So that's 37 degrees, as you can see here. So 37 degrees, 49 degrees. Right, that's good. All right, so let's look for some clues. For the third time, we are reminded that if a diameter is in a circle and for some reason lines are projected from the ends of the diameter, then that means more than likely a right angle triangle is formed. And therefore this angle right away is going to be 90 degrees. I know that much. We also can recognize here that since OA and OD are radii, then they're also equal, which means that this connection that I formed down here prior while looking for my clues forms an isosceles triangle. So these two angles down here are going to be equal. Not only that, these two angles are also going to be equal here. This one and this angle here marked 37 is going to be equal. So right away, I already know that that angle is 37. I don't know if I'm asked to find it, but I know for certain that that angle is 37. Right? So this angle here, let's just mark it with a different color, because I don't want you to think that all the angles that are marked in green is equal to 37. It just so happens that this length and this length is equal, so this angle and this angle is equal. Let's just indicate it with a different color ink here. So it is this angle here and this angle here that's going to be equal. All right, and these two green angles here are going to be equal, although all three sides or all three radii are equal. All right, so it forms different triangles, which means that different angles will be formed. We'll also notice here, even before getting into the question, that there's an angle that is formed at the center of the circle. So that brings in mind the central angle theorem. So more than likely, if we can project it towards the circumference, then you're going to find that the angle that is at the center here is going to be twice the angle at the circumference. Let's have a look at that. So here I have a chord BA that basically creates the angle at the center that is marked by X here. Notice that that same chord BA, it projects the red line towards D, and it projects also this imaginary line that we had indicated here towards D. So also this angle is somehow related to this angle at the center. And how is it related? We're going to learn that X, let's just make a note of it here, X is going to be equal to, all right, let's just make a note here. All right, so the angle that is marked by X here, all right, is going to be two times the angle that is at D. It's going to be 2 times the angle at D. All right, so if I know what the angle at D is, I can multiply it by 2 to get the angle at X. If I know what the angle at X is, then I can simply divide that angle by 2 to get the angle that is at D. All right, so lots of little relationship has been created here, and as you can see, guys, I have not even looked at what they're asking me to find. All I'm doing is that I'm looking at the question, I'm analyzing step by step all the little clues that we need, and then from there now we can look at using the clues to pin together what is it that they're asking me to find. It says that we should write down the mathematical names of the straight line BC and OA. So the straight line BC, okay, BC, that's a chord. And we should write down the line OA. What's the name of the line OA? That's a radius. Right, so little fun start here, right? Little fill in the blanks for you to start get comfortable. All right, so BC is a chord and OA is a radius. All All right, let's continue. It says here that we're to determine the value of each of the following angles, show detailed working where necessary, and give a reason for the answer. So we need the angle that is marked at X. And we can easily find the angle that is marked at X, because earlier we were given the fact that this angle here is in fact 37 degrees. So we know it's 37 degrees, and we also know that the angle that is over here is also 37 degrees, and those two 37 degrees along with the X is inside of the triangle BOA. So we can safely say then that from triangle BOA, angle X is equal to 180 minus 37 plus 37, or 37 times 2. All right, because there's two of them, so it's 180 minus, say here, 74 degrees, and then you're gonna find that that angle is 106 degrees right in the center there. All right, so the angle that is marked at X here is 106 degrees, and so we can safely say that there's actually two statements that can back up what we have just done. We can say that one, radii of the same circle are equal, which therefore forms, triangle BOA is isosceles, and we know that an isosceles has base angles equal. And then we can also solidify what we have, the sum of the angles in a triangle sums to 180 degrees. All right, so this statement here is the reason why we said that 37 times 2, because the radii are equal, and this statement down here is the reason why we subtracted the 74 from the 180 to get 106 degrees. All right, so that is one or two of the reasons that we could use to get that angle. We're going to move on next then to, I believe that was it. That was the angle marked X. Okay, so we need the angle that is marked by Y. So where is that angle that is marked by Y here? That is the angle down here. All right, so we can actually find this angle easily. All right, and remember that we had indicated that this angle here is 90, right? And that was from when we were searching for the clues. Now let's just imagine that we didn't indicate that angle that is marked by 90. Then perhaps you would have to be thinking about what that angle is. But we already knew that the angle was 90, because we know that BD is a diameter that subtends an angle at C. So we're going to save this, then go ahead now, and we're going to say then, all right, since diameter BD, okay, so since diameter BD subtends an angle at C, therefore angle BCD, let's confirm that, angle BCD equals 90 degrees. All right, and that is all because the diameter subtends an angle at C. That's why BCD is 90 degrees. So as a result of all of that, alright guys, so as a result of that, we can see then hence angle, alright, so hence angle Y, is going to be equal to 180 minus 90 plus the angle that we have at the top, which is 49 degrees. So 90 plus 49 degrees. So that's going to be 180 minus 139 degrees, which works out to be 41 degrees.
All right, that works out to be 41. And so the reason for that would have obviously been one of the reason, and the other reason would have been the fact that the sum of the angles in a triangle sums to 180 degrees. And I know that a lot of you guys, you really cannot be bothered to write the statements, but these statements is what CSEC is looking for. It is what CSEC is looking for in order to give you your full marks. You need to show them that you understand clearly what needs to be done to get to your answer. All right, so that's pretty good here, guys. All right, so I'm gonna bring this particular video to the end. Right, we're just over an hour, so that would have been 4. So I'm gonna just refer to this as part 1, so you're gonna get part 2 a bit later. Let me know in the comment section if you enjoyed the video, if you learned something new. As you can see, I have another 8 pages of questions to do. This will take us all the way to 2023, so we are ending this video at 2020, so we have 3 more years of past papers to do. We're gonna see you in the next one, so do take care until next time. This is Akin, your math instructor. Bye bye. Do not forget to subscribe, like, and share.